In this video, we will solve problem 5.27. So we have to check the consistency of the equations. So in A part, we have to check that 5.63 equation is consistent with 5.61. So this 5.61 equation and this 5.63. So I have written these equations in these boxes. So 5.63 equation is this, 5.61 is this, 5.45 is this, and 5.62 is this. Let's get started. Before solving the questions, we have to revise some concepts. First of all, that there are two set of coordinates that are primed coordinates and unprimed coordinates. These are unprimed and this is primed. So B is the function of x, y, z means unprimed, and J is a function of x dash, y dash, z dash means primed. So B is a function of unprimed coordinate system and J is a function of primed coordinate system. So there are 2 points that are source point. So source point and field point. So source point is the point where charge is located, and field point is the point where we have to find the field. So where we have to find the field. So these are 2 points. So let's say this is the, let me change the color. So let's say this is the origin, So from here, let's join this and let's join this. So as this is written, this is r vector and this is r prime vector and this is r unprimed. So I will basically say r vector. From here I can write r prime vector plus r vector is equal to r vector. So when I am speaking, you may think these are the same things, but in writing these are different, so please be careful. So from here, that r vector is equal to r vector minus r prime vector. So from that, we have already said that J is a function of prime coordinate points and B is a function of unprimed. So this is unprimed and this is primed. Now if I have gradient, if I have a gradient operator, then the del, this is the del operator in the unprimed coordinates, and this is the del operator in primed coordinates. So what are the relationship between them? What is the relationship between both? So we can switch from del to del prime at the cost of minus signs. So let's say this is del of r. If we want to switch from unprimed to prime, then it will be minus of del prime r. So how I wrote this? There is a technicality, there is a just a differentiation concept. Please let me know in the comment section okay, what is this concept, why I wrote this, why I switched to unprime to prime at the cost of minus sign. Now there are three things. First of all, this gradient of 1 upon r is equal to minus r cap over r square. This is the first. Second, that divergence of this r vector over r square is equal to 4 pi delta q r. 4 pi delta q r vector. So what is delta? This is the Kronecker delta. This is the Kronecker delta. So the property of Kronecker delta is this: when you integrate from minus infinity to plus infinity, then f of x del of x minus x naught dx, then in place of x in fx it will be x naught, so f of x naught, and we will use in this question, that's why I told you. So let's get started to the problems that are mentioned in this question. There are three problems in this question. So in first we have to check the consistency. So we have to basically prove this del dot a is equal to 0. So let's take divergence. So del vector dot a vector is equal to mu naught over 4 pi. So when I take del, it will go inside the integration, so I will write it directly: del j r vector over r d tau dash. So I will use the property of this divergence, that will be equal to del vector dot a vector is equal to mu naught over 4 pi integration of, so first is j r dash j vector r dash and del of 1 upon r plus 1 upon r del of j vector r dash, del of j vector r dash, and this is t tau dash. Okay, so as I said that this del, so as I said this del is in unprimed and this j is in prime, so it will be 0. It will be 0. So del vector dot a vector is equal to mu naught over 4 pi integration of j vector r dash del vector over 1 upon r and d tau dash. Now I will switch from del to del dash. So when I switch, it will be minus mu naught upon 4 pi j r dash del dash dash del prime over 1 upon r d tau prime, and I use dash or prime, which is the same thing. So why I switched to prime, because this integral is in the primed coordinate, so I had to switch. So when I switch, now I have one thing to add in this. When I find out the del dash j vector r prime over r, it will be 1 upon r del vector dot j vector plus j vector dot del prime 1 upon r. So this is del prime dot j. So in magnetostatics, because they are in both primed coordinates, this is also in primed coordinates. So but in magnetostatics, this is 0. So del dot j is 0 in magnetostatics. From continuity equation, you can see this is 0. So del dash j r dash over r is equal to j vector dot del prime over 1 upon r. Right. So this del dot a become minus mu naught over 4 pi del prime j vector r prime over r d tau dash. So using divergence theorem, let me write it, divergence theorem. Using divergence theorem, we can write it as del vector dot a vector is equal to minus mu naught over 4 pi. So integral over the surface j r dash over r, and this is area integral, so dA. So J, that is volume current density, is entirely inside the volume. So on the surface it will be 0. So the whole integral will become 0. That is the proof of del dot A vector is equal to 0. That is the consistency check that del vector dot A vector means divergence of vector potential is 0. Now coming to the B part. We have to find out that BR from that AR. So as we know that that B vector is equal to del vector cross A vector. So I have to take the curl of that A. So when I take curl mu naught over 4 pi, it will inside the integral. So del vector cross J r dash over r d tau dash. Now let me write the one identity that del cross f a is equal to f del cross a, that's a vector, so this is a vector, minus a vector cross del f. So I will use this identity while opening this. So this will be mu naught over 4 pi, this 1 upon r, and del vector cross j vector r prime minus j vector cross del of 1 r, that is d tau prime. So as I said, this is in unprimed and this is in prime, so it will become 0. So it will be equal to mu naught over 4 pi, that minus will be here, and j del of 1 upon r d tau dash. So as I wrote the formula that del of 1 upon r, what I wrote, del of 1 upon r is equal to minus, so this is cross in between, so j cross del 1 upon r, so this is minus, so del of 1 upon r is minus r cap over r square. So B vector is equal to minus mu naught upon 4 pi and j cross r cap over r square d tau, and the minus of this will become plus. So this is this equation, right? Now coming to the C part. In this problem, you have to, from the vector potential, you have to get this, right? So you have to take the Laplace of A. So del square A will become mu naught over 4 pi j r prime over r d tau dash, and this is the front of del square, right? This is the front of del square. So this will be equal to mu naught over 4 pi, and inside the integral it will open up. It will open up. So let me open it. 1 upon r del square j r prime j r prime plus j vector r vector prime del square over 1 upon r, and this is d tau. As I said, this is unprimed and this is primed, so it will become 0 because there is no dependency between them. So when you differentiate constant things, it will be 0. So it will be mu naught over 4 pi integral of, this is d tau prime. So 1 upon, so this is j vector del square 1 over r d tau dash. Now I told you in the starting that del square 1 upon r is del of 1 upon r, and I told you that del of 1 upon r is minus r cap over r square. So del of minus r cap r square is minus 4 pi del cube r. So r is what I wrote. R is, so this will be minus k 4 pi del cube minus k 4 pi del cube r minus k r dash. So when I integrate it, that mu naught over 4 pi, I told you the property, right? Use this property. You have to use the Kronecker delta property, that j vector del square that I have to put, that is minus, will be outside of the integral. So 4 pi del cube r minus k r dash d tau dash. So let me write it properly, that is r dash vector. So 4 pi will cancel out. So let me change the color so that it will be distinguishable. So when I integrate it, because we are integrating in the primed coordinates, so the primed coordinates will replace by unprimed. So that will be del square A is equal to minus k mu naught. So when you use this property, that r dash will be replaced by r, so this will be jr. So this is the equation 5.62. That's how you can approach this problem. It is a bit tricky. You have to use the coordinate system of unprimed and primed coordinate. That's why I explained in the starting. Thank you.